Okay, so for this next problem, problem number 16, it says segment JK is shown on two coordinate grids. So we've got this grid and this grid. And these are two different JK lines, as you can see. They've got different coordinates. So then it asks, determine the coordinates of point N on JK so that J to N is 3/5 of J to K. So really, this is asking you to find the 3/5 point from J to K. All right, I'm going to do this graph first, and then I'll do this graph. First, I'm going to go ahead and connect J to K on this graph here. Okay. So with this graph, we're working with pretty clear-cut coordinates, and we're going from 0 to 8 and 0 to 6 on this x and y axis. So for this problem, I'm actually just going to use the rise and run to find my 3/5 point from J to K. So we do that if I draw my rise and run. So here I'm going over So I'm going over 1, 2, 3, 4, 5. And I'm going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the way that you find your 3/5 point, and I'm going to do some scratch work over here. Okay. We're going to take our run and multiply it by our fraction 3/5. Okay. And that gives us 3. I prefer to just do it in parentheses. You can also press alpha y equals and type in the 3/5 fraction and get the same answer. Okay, so what this means is that instead of running 5 to the right, the new coordinate is going to go 3 to the right. Okay. Then I'm going to take my, this one is my run and this one is my rise. Okay. Multiply that by 3/5. So 10 times 3/5 gives me 6. Okay. So instead of going down 10, now I'm going to go down 6. Okay? So we'll go over 1, 2, 3. 1, 2, 3, 4, 5, 6. And that's my 3/5 coordinate. So that is at the place 2, -1. Okay. Okay. For the next one, the coordinates aren't quite on an even location. J is at 2.550 and K is at 55 and 5. We're also increasing by amounts of 5, it looks like, on this graph. So I'm actually not going to use the rise and run method for this problem. Hold on 1 second. Okay, so for this problem, instead of using the rise and run with just drawing like we did in the last one, I'm actually just going to use the coordinates. But it's sort of the same idea. So we're going to get the length of our run by subtracting the x values. Okay. So 55 minus 2.5 gives us 52.5. Okay. And then we're going to take this amount and multiply it by our fraction 3/5. This is like your run, okay, since this is dealing with our x values. Okay, so 52.5 times 3/5 gives us 31.5. So this is the new amount that we need to go to the right. So originally what this is telling us is that from 2.5 to 55, the run is 52.5. But when we multiply that by our fraction, what that tells us is that now, instead of going the length of this horizontally, we're going to go the length of 31.5 horizontally. So the way that we do that is we just add it to our original x coordinate. Okay. So 2.5 plus 31.5 gives us 34. This is the new x coordinate for the 3/5 point. Okay, so I've got half my answer right now. All right, for the other half of the answer, okay, I'm going to do the same thing, but with the y's. So my j was starting at 50, okay, and k was 5. So when I subtract my y's to get my length, okay, that gives me a length of 45. Multiply that by my fraction of 3/5. We get 27. Okay, so here's the thing. My starting point is at 50. Now, to get my x, I took this number and I added it to my original value. But if we add 27 to 50, that's going to go way up here, somewhere off this graph. K isn't above j, k is below j. So instead of adding this 27 to the 50, we need to subtract, because we're not going to the right and up, we're going to the right and down. So when you're moving in the right direction, you're going to add. When you move in the left direction, you subtract. When you're going up, you add. When you're going down, you subtract. So I'm going to subtract this 27, and that gives me 23. Okay? And that is my, that is my 3/5 coordinate at 34.23. So if I were to plot that, so there's 35, okay, so it's somewhere around here. 23, so probably about there is our coordinate.